Hi there, I'm Hao, and this is just another video of me solving random code problem. So given the head of a linked list, delete all nodes that have duplicate numbers, leaving only the distinct number from the original list. Return the linked list in sorted order as well. So um, we have a sorted linked list, right? So because it is sorted, we know that we have a huge advantage, right, to do it in one pass because the array is already sorted. The linked list is already sorted, which means all of the duplicate numbers are always next to each other, right? So we can just skip them. Okay. Then you're gonna have the linked list here, 1, 2, 3, 4, 5, right, and then no, right? We're gonna create a dummy head, a new head, right? A new head to return, right? And the new head gonna pointing at the original head, right? Right. Why did we have to create a new head? Because as you can see here, right, the first node might also be the duplicate, right? So if it is a duplicate node, we just want to delete everything, right? We just want to return only the distinct node in sorted order, right? So in the first example, we get rid of 3 and 4, and we have 1, 2, 5 left. Okay. So because the first node might also be the duplicate, so we don't know yet, right? So we set like a new head here, right, to avoid the edge cases. Right, so our strategy is pretty simple. We're gonna have a current pointer, right, pointing at the head, at the new head, right, and then we just keep compare the head element value and the head dot next value, right. If they are different, then which means we increment the curve, right, to point to the next element in the list, right. And if it is duplicate, we're just gonna skip them. Okay, so so now we compare, right? If head has the next element and then head is equal to head dot next, right? In this case, no, it is not equal, right? So we increment the curve to the next, right? Okay, and we increment our next head, our head pointer. Okay, now we go comparing. I think I'm missing a note here, right? 3, 3, 4, 4. Let me just add that quickly. 3 and 3. Okay, 3, 4. Okay, so now we compare again, right? Head and head dot next. So the value are different, which means we want to keep the first two nodes. So we increase our current pointer, right? Increment our head. So now the head value is equal to the head dot next value, right? In that case, we just keep incrementing head until we find different elements, right? So now they are different, right? 3 is different than 4, so we just stop, okay? And at the end, right, we always increment the head pointer regardless of what happened, okay? So now we compare again. Are they equal? Yes, they are. No, they are not, right? Which means they are have a distinct element. So we want to um set the code of next, right? Code of next here equal to head of next. Uh, wait, sorry. I think I forgot something. Let me go back. All right. So let's use the color blue to indicate the let's use the blue color, right, to indicate our range of our new array. Sorry, new linked list, right? So let's say our head is here, right? The values are different, right? So we're gonna increment our current uh, pointer, right? So which means it is valid. So we increment our current pointer to here, right? And then we increment our head, right? Now they are different, right? 2 and 3 are different. So I have to increment the curve pointer, or so this part is valid. And we increment our head pointer, right? Now they are equal, right? So we need to keep incrementing the head. Right now they are different. right? So we have to keep increment the head pointer until the head and the head dot next have a different value, right? And then we always incrementing the head at the end. So before we incrementing the head, we need to set the next pointer of the curve, right? So curve dot next equal to head dot next. We want to skip the duplicate element here. Okay. So curve is still here, and then we increment the head. Okay. So because now they are different, right? So we increment our current pointer to curve dot next, which is 4 here, not 3, right? And we incrementing the head, right? Now it doesn't have the next, right? Or you can think of it like they have a different value. 5 is different than no. So that is valid. So we increment our current pointer again, increment the head again, and now we are about, right? So we are done. So at the end we can return the new head, right? But next, which give us 1, 2, 4, and 5. Okay. So our the example here is different than this example, right? I only have one number 4 in this example for simplicity. Okay, so let's look at another example here, the second example. To see what happened, right, in the edge case, right, when we have a duplicate in the front, will it cause us any trouble? 3 and then no. Okay, so again, this will be our new head. Okay, so now, so we start out, right, the curve pointer is pointing to the new head, right, which means right now we have 0 valid element, right? Our new linked list is still empty, right? Our new linked list is determined by where the curve ends, right? So we compare, like, the head and the head dot next, they have the same value. So we need to keep incrementing the head, right, until uh, head and head dot next have a different value, right? Okay. So now it had a different value. We need to set the pointer, right, of the current, right? So curve dot next, right? Curve is the new head here, right? Dot next, which is this pointer right here, equal to head dot next, right? Okay. And then after that, we have to increment our head pointer. Okay. So note that our curve is still here. Our curve is still here, right? Because we only skip the duplicate. We only skip the duplicate elements, right? Which is what is it? 111, right? Uh, this might be 222, right? Who knows? So we don't know if this number is valid yet, right? So that's why our curve is still here until we check it, right? Now we check it. 2 is different than 3 because they are different. So we can safely increment our curve pointer, right? Curve equal to curve next, which is here, right? There's a valid element, and we increment our head, right? So now 3 is different than no, right? So we can safely increment our curve again. We increment our head. Now it is our bow, so we can just return new head of next, right? We give us 2 and 3 because we are pointing at 2 here. Okay. So our space complexity gonna be constant, right? And we can do it in one path, which is O of n. Okay, so let's put this up. So we need our new head, right? Equal to new list node. So we have a next option here, right? So we can pass in a value of 0. It can be anything, doesn't matter, and the value of our head, and we can return a new head, right? Next at the end. Okay, let's current equal to new head. So y head, right? So if head dot next, right? If head has the next pointer, head have the next value, right? Have the next node, and then has dot next that value is equal to head dot value. Else, okay. So so if the value are different, right? We can just increment our current pointer, right? That's it, right? And we need to increment our head regardless of what, right, at the end, right? If it is a different node, right, we want to move on to the next node in the head, right? If it is the same, we also want to increment our head pointer, like one step at a time. So as I said earlier, the current pointer position, right, indicates the length of our new linked list, right? So where so the position of the current pointer indicates that the node the current pointer is pointing at is valid, right? From the current node that the current pointer is pointing at all the way back to the new head is valid, right? So if the value of the head and the head of next are different, which means the value at the head now gonna be valid, right? So we increment our current pointer to show that. Okay, so if they are the same, what do? We need to keep incrementing the next pointer, right? Until we find a different value. Okay, and then we find after we find that the head dot next and the head dot next dot val, right, are different, right? Remember? So at that point, our head is still here, right? Head dot next and head are different, right? So we need to reset the next pointer at the curve to point to the next node. Well, because we want to skip we want to skip the duplicate elements, right? So we have to set the curve, right? So the curve, previously the curve is still pointing here, right? Right. We still skipping all of the duplicate elements here. So when the head and the head dot next 1 and 2 are different, now we need to reset the next pointer of the current, right? So previously the new head is pointing to here, right? It's pointing to here. It is our head, right? Head, we compare head and head dot next. 1, 1, 1 right now. Finally, head and head dot next are different. So we need to reset the curve pointer, right? Curve is the new head. Curve dot next equal to head dot next, right? So curve dot next equal to head dot next, right? And then we need to increment our head pointer one more time, right? To get rid of the last duplicate element. And we already did that here at the end, right? Okay. And yeah, that's pretty much it. Let's give it a try. Okay. Thank you for watching.